Okay, looking at further steps, so far we've seen ones where the numerator and denominator are perfect squares. We've seen ones where you can divide the bottom into the top or vice versa. Actually, the bottom just in the top. Now, simplifying radicals is a different way. I'm going to show you this problem again, this time with simplifying radicals. So what we're going to do is we're going to take root 48, and we're going to figure out what perfect square goes into 48. So that was, let's see, 1, 2, 3, 4, 5, 6, 36, 49. So 48's here. The next one that goes in 16. 48 is 16 times 3, which would be square root of 16 is 4 root 3. Then we look at root 12. Well, root 12, let's see, 12 is here. 4 is the perfect square that goes into 12. We get 2 root 3. So now we have 4 root 3 divided by 2 root 3. Now, if we look at the 4 and 2, 4 divided by 2 is 2. And then root 3 divided by root 3, it's the same thing divided by itself, so that reduces to 1. So 2 is our answer, which is what we got before when we did that problem. But that's another way to do it, is by simplifying radicals. Now, the last step 4 was rationalize the denominator. What does that mean? Well, right here in bright red, you cannot leave a radical in the denominator. Okay? That's just mathematically, you can't leave a radical in the denominator. So what we need to do is called rationalize the denominator. Okay? This involves multiplying the numerator and denominator by a factor that eliminates radicals in the denominator. Now, what does that mean? Well, if we have something times 1/2 and we multiply the top by 2 and the bottom by 2, we get 2/4, which we know that 1/2 is equivalent to 2/4. So as long as we multiply the same thing by the numerator and denominator, we get an equivalent fraction. So how we rationalize the denominator is you're going to multiply the numerator and denominator by a factor that eliminates radicals. Well, to get rid of radical 5. We learned back in topic 2, if we do radical 5, or topic 3 I guess, radical 5 times radical 5, what does that give you? That gives you radical 25, which is, yeah, that's 5. So if we multiply by radical 5 over radical 5, that's basically just multiplying by 1. So 1 times root 5 is root 5. So we get root 5 over 5. And remember, you cannot simplify those, because the top 5 is underneath a radical, the bottom 5 is outside of a radical. You cannot simplify inside to outside. Okay? So let's look at the next one. We have root 7 over root 3. Root 7 and 3 do not simplify. Neither of them are perfect squares, and 3 does not go into 7, so it doesn't simplify. So we need to rationalize. So what we're going to do is multiply the bottom and the top by root 3. Okay, because what is root 3 times root 3? Yeah, root 9, which is 3. And then on the top, root 7 times root 3. Neither of them simplify, so we can just do root 7 times 3, which is root 21. So we get root 21 over 3. Again, you cannot simplify the 3 into the 21 because 3 does not have a radical, 21 does. So your final answer would be root 21 over 3. Okay? Go ahead, do the U-try, have fun with that, and we'll see you in the next class.